So this is the new SMA Sunny Boy inverter. It's their TL model. This is a 4,000 watt. It's unique compared to the older models due to the fact that it allows you to install a switched outlet. The standard grid-tied inverters, once the utility power goes off, you had no power. Now in this system, what it allows you to do is as long as you got sun power, granted, you know, that power will fluctuate, you will have power in this outlet without having to have a standby battery backup system. Now this, they call this a secure power supply system. It was interesting. I was trying to figure out how to connect it before I purchased it. I had very little information online, but basically you have to have a qualified electrician to install this section here, and they want a switch that controls your receptacle. So if you look in here, there's this is the two switch wires on the top two, and then the bottom three is your receptacle. The utility power company comes into here, so that's pretty self-explanatory. You got a line 1, neutral, and a line 2, and then in the back side you have a ground. Now this is obviously switched. There's a means of disconnect for this and an over current protection device connected elsewhere, and that's required by the National Electrical Code. This inverter comes with an access here for a future upgrade for exhaust fan. What I like about this, it comes with a whip pre-made. There's no reason to go inside of here, and basically these are just color coded. It goes into your DC combiner box. Your DC combiner box. Also, it comes with arc faults protection in there, I believe. And here I just have one string, so basically it's just a negative and a positive going in there. So I'm in the process of commissioning this. The reason I had to, I had an older one here, I had to replace it, was because there was an indirect lightning strike or a big surge and it fried the capacitor. And according to SMA, that was something that the manufacturer did not guarantee a warranty. So I am going to be installing an surge suppressor on the DC side and a surge suppressor on the AC side. So what I'm going to do is I'm going to close this up and put the cover on and turn it on, and we'll monitor this and see how it works. Oh, by the way, wanted to mention there's these dials here, A, B, and C, and then there's a dip switch here. If you look at the instructions, these are for language and area or country. So basically make sure that you read your instructions on how to program this. Now I left it on the default mode because I am in the United States and there's English. This is programmed for English, and it will detect the nominal voltages of the power grid I'm in. So I went ahead and turned the power grid on, and LED light came on here. You can see there some activity. I'm going to turn on the DC. So this will engage our solar array. And we should see some light blinking here in a second or two. So we got light blinking. There's some relays that should start clicking here in a second. There we go. I just heard the first one. So what we want happening is we want this light to stay on constant. So what it's doing, it's going to go, it's testing. It just did this arc fault testing. And it looks like we're solid green. So we're engaged. Now if you look at here, there's this little diagram. What it represents is two strings. I only have one string, so this string is not connected to 0. But when it jumps over, you'll see the power come on, or you'll see the gauges here. There it is, 326 volts at 249 going back into the grid, and it's shooting 12.2 amps right now back into the grid. Now we can cycle this. You gotta do is just knock it. There it is. Now, what I like to do, I'm going to mimic a power failure from the power company. So even though right now we're feeding back into the grid, making that meter spin backwards, let's assume that there's a power outage. And usually in a typical inverter, you won't have any power unless you have a standby hybrid / battery backup, which I don't here. So if that's the case, we want this thing coming on. So I'm going to go outside and disconnect turn off the disconnect. Alright, so I just turned off the disconnect, and as you can see, there's a diagram here that shows there's an open switch to the utility. So we can see the electronics monitoring that very accurately. Now the idea is there's a switch that we're supposed to install, which is this one. So this should turn on the power. I'm not sure how long it'll take. Okay, so I paused it. It took about a minute or so. I heard some clicking noises, and as you can see down here, there's my GFI. There's a trip in the indicator light, so I know I have power. Just reset it, so there it is. It's working. I put a voltage test on my GFI. Okay, so I went ahead and put a meter on it. So I went ahead and put the hold feature. So there's 122 volts being produced. Now, according to the specs, the available power is really about 10 amps or 12 amps. Make sure you read your instructions and design accordingly. One of the good ideas, or I think with this, is you can actually connect a charger to this and supplies, charge a battery bank in addition to the system, and I believe you can make it's very versatile. You can use it as a hybrid type of configuration. So let's say you have a separate battery bank that you like to charge up, and you have a separate inverter, one of those modified inverters, and you just want to use it to operate certain heavy equipment. You could potentially use this to charge that up, and that this would be enough power to do that. And then use the modified inverters or pure sine wave inverters to operate your other heavier equipment. So anyways, that's my input on this new model. And I'd like to hear your guys' questions or comments. If you'd like to, please post below. Thank you.